Okay. So we're on page 14. That's where we left off. So let's summarize what we did last time. So there's some people gone. Ari, what's one thing that we learned?
It talks about angle and angle measures. And we practiced like graphing positive and negative angle measures with the initial side and the terminal side. And then we worked on radians. And then we converted degrees into radians and radians into degrees.
Cool. So every single thing she said pretty much summarized last time. So let's just look out for a sec. So first, this point right here where my two rays touch, what do we call that, Jeremy? It is the vertex. The vertex is at the origin for our drawing. And then what is the first ray called? What's the ray that's located along the positive x-axis? Initial. Okay. And then what's the ray that's located up at this angle? Terminal. And the angle goes from the initial to the terminal. Is this a positive or negative angle? Positive. How do we know? It's positive because it's going counterclockwise. So if I was going to draw a negative angle, let's see what this would look like. All right, here's my angle right here. And since I'm going clockwise, this is going to be a negative angle. Okay, cool. So that summarized the first half. And then as Ari was saying, we learned how to do degree to radian. So we're going to continue. With that. So let's go ahead and let's do. Did I have an example here? No. It's fine. So to go from degree to radian, literally this is something you should box in your notes. Degree to radian. You're just going to multiply by pi over 180. Sorry, you said you had a question? You just want to do it? Okay. And then we're gonna finish our last couple examples when we're going radians to degrees. But you should have this ready because the example after that, we're going to practice degree to radian, then radian to degree. Get it all mixed up. That way you know which one to use. Degree to radians, you're multiplying by pi over 180. Because it will cancel out the degree, and you'll be left with something with pi. All right. And someone that's not Ari, who already spoke, what's radian mean? What's a radian? Matt?
It's like a radius.
It is close. It has something to do with radius. Stessa?
It's like when an arc of an sector is the same length as the radius.
That's literally the exact definition. That was good. The radian is the angle whose terminal side intersects an arc length with the same measure of the radius. So we went over this yesterday. Literally this length of the arc, this part of the circle, is the same length as the radius. And so when that happens, you have a degree, you have an angle measurement of 1 radian. All right, so let's continue where we left off, which is E on page 14. So I'm going from radian to degree. How would I do that, Cheval? What should I do?
Multiply 180 over pi.
Cool. So the pi's will cancel out. 180 divide by 3. Cheval, you want to finish the question? How do I simplify that?
You can cancel out the 0 and then do 18 is 6. And then 3 is 1.
Yeah, so 3 goes into 18 6 times. So 3 goes into 180 60 times. So the 0 here doesn't cancel out, but it's close. You're close, because before what we were doing when we had zeros on the bottom, we could cancel them out like, trying to look, where was the last one? Like this one right here. Oh geez. Like this one, the zeros cancel out because they're both divisible by 10. So down here on 14, they were both divisible by 3. So if I would cover up the 0, 18 goes into 3, 3 goes into 18 6 times, so 3 can go into 180 60 times, so a factor of 10. Solid, and now let's go, question? You gonna do F?
Yeah.
Okay, do you have a question? Yeah. All right, so let's do F.
So you multiply by 180 over pi, and then you cross out the pi's, and the 2 of the pi, times 180 over 6, which is
So you said 900 degrees over 6, and you put that in your calculator. 900 divided by 6 is 150 degrees. Solid. All right, so that finishes out this example. So we can continue on to the next one. All right, for each angle, we're going to find one positive and one negative angle that's coterminal. So what does coterminal mean? Do we remember? Okay, besides Ari, Liana. Hey, what's coterminal mean? Okay, so if you have a co-ed team, what does co-ed mean? Huh? You have both. Okay. So if you are co-managers, what does that mean? Co-managers of, I don't know, McDonald's. You share the responsibility. So if you're co-terminal, exactly, you share a terminal array. So co is like sharing, and terminal is the terminal array. Okay, so literally, remember when we were, not far enough, here. All of these are coterminal angles because they all have the same initial ray on the x positive axis. They have the same terminal. So the difference is, am I going positive angle straight to it? Am I going around the negative direction? Or am I going around more than one time? I can go around 50 times if I start and end at the same place as the other angle. They're coterminal. So I believe the example we used yesterday of where this comes in handy is if you have a car and you're driving from Fallbrook to Topanga. Imagine how many times your wheel would turn. So I can have a coterminal angle that's between 0 and 360 with that hundreds of wheel turns. Okay, so we're looking for angles that have the same terminal ray. Okay. How do you find a coterminal angle? What do I add or subtract? Ari?
You add 360 or subtract 360. To find a positive, you add 360. And to find a negative, you subtract 360, except for sometimes you have to do both depending on the outcome.
Cool. So 360 is for degrees. So what should we use for radian measures? Chloe, do you know? What should I be adding? So I'm adding degrees with the radian. What would be easier? Add or subtract? So what is the radian equivalent of 360 degrees? So radian equivalent. Oh no, okay, let's look back at page like 12, 11. So I'm expecting you to turn back to look at how we find coterminal angles and what radian equals 360. What radian equals 360? 2 pi. Okay, so instead of adding or subtracting 360, I'm going to add or subtract 2 pi. So when I have 2, I'm going to find a positive coterminal, so 2 pi over 3, and I'm going to add 2 pi. So Ethan, what is my denominator for 2 pi? 1. Okay, can I just add these across, so 4 pi over 3? Ethan, what do you think? Need a common denominator, so how would I do that? Times by 3 over 3, because that's a clever form of 1. So I'm not really changing the problem, I'm just multiplying by 1. So this means 2 pi over 3 plus 6 pi over 3. And now when I add them, Ethan, you want to finish out the problem?
Yeah.
Yep. Can I reduce that at all? Nope. Cool, so now I need to find the negative. So instead of adding, as Ari said, we're going to subtract 2 pi. So trick play, because we already know the common denominator, I already know exactly what to do. So instead of adding, I'm just going to subtract it. So this is going to be, let's see, multiply by 3 over 3. Oops. Make it consistent. Multiply by 3 over 3. So I have 2 pi over 3 minus 6 pi over 3. And I will get negative 4 pi over 3, and I cannot reduce that at all. Alright, so when you're finding coterminal angles, the positive one literally has to be positive. The negative one has to be negative. What would I have done if I had gotten a positive number when I subtracted 2 pi? Michaela, do you know? What would I have to do? If I had gotten a positive number after I subtracted 2 pi,
You would have to make it, you have to do it.
I'd have to do it again. So that's the trick, is like, we have to make sure our negative coterminal angle is actually negative. We have to have a negative sign in front of it, so you have to keep subtracting 2 pi until you reach a negative number. So that means I picked a number that had such a big angle, it went around positive more than one time. All right, so that was kind of a trick question. So now let's do B. What's wrong?
So I didn't do 2 pi over 3. I just turned
It's not, oh, what do you mean 2 pi over 3?
I multiplied by 180 over pi and changed it into an angle.
Ah, see, on your test, I'm going to make you do it both ways. I'm going to say you must stay in radians, you must stay in degrees. So you have to know it both ways. So it's good you know how to convert, but I also want to work on fractions with you guys. Yeah. Tessa?
So do you always add? Oh, is this just showing like? Okay,
because imagine adding. I see what you see.
We're adding
360.
We're trying to get to coterminal when we were in degrees.
Yep, and that's just adding literally 1 revolution. So adding 2 pi is 1 revolution.
Okay, so whenever you see like it in radians, you're always gonna add 2 pi.
Yep, for coterminal.
Okay. You said you'll have to like keep.
Yep. So there's an example later. Just wanted to kind of like plant the seeds. So then later you're like, oh, this is it.
Okay, so it's also a positive.
Yeah. All right, so let's go to B. How would I finish this one? Zach, how would I start this for positive?
Plus 2 plus negative 7 pi over 4 and then plus 2 pi
Mm-hmm.
around 1. And then you have to multiply 4 over 4, which would be negative 7 pi plus 8 pi over 4.
Oops. Negative 7 pi over 4 plus 8 pi over 4. So what I get here, Zach?
No, just pi over 8. No.
Pi over 4, perfect. Lead me through the negative one, if you don't mind.
Here you do negative 7 pi over 4. Negative 7 pi over 4. And then it would be negative pi over 4 minus negative 8 pi over 4. And then the negative.
Sweet. So double checking, we have 1 positive answer, 1 negative answer, so we're solid. Just as an exercise, we can try graphing this one, just to prove that these are coterminal. Do we remember how to label our axes? So I start at 0, and then, how do I go around, Jonah? What should the y-axis top, what should I label it as?
90.
So 90, or in radians, what is this? In radians, do we know? Okay, close. So if I go all the way around, I'm 2 pi. What if I go halfway around? What would I label this as?
Pi.
As pi, because half of 2 pi is pi. If you have 2 pi's, half of that is 1 pi. Okay, so if I'm halfway between 0 and pi, it will be 1/2 pi, as Maya said, or I could say pi over 2. What about, let's see, so label this as 180 degrees, so we know what that is. And I said 0 is the same thing as 2 pi or 0. What about this bottom one right here?
270.
So 270 degrees, or what would this be in radians? Start at 0, 1/2. 1, 1.5. What's 1.5 as a fraction? 3 over 2, so 3 pi over 2. Because it's 1.5. Okay. All right, so now let's try labeling this. So the first thing I have is, let's do 1 pi over 4 first. How do I know where pi over 4 is? I don't. Do I? I don't know, Carson, what do you think? How do I find where pi over 4 is?
I mean, well, it's only bigger than pi over 2.
Let's see, is half of a pizza bigger than a fourth of a pizza?
It's really small.
Ah. So it's going to be between pi over 2 and 0. Strictly speaking, it's exactly halfway between 1/2 and 0. Because half of a half is a fourth. So half of pi over 2 is pi over 4.
Do you still want to graph this on a calculator?
Sorry, what?
Do you still want to graph on a calculator?
I mean, no. Not right now. I'm not going to tell you to do it. So, because I want you to do it on the paper. Because you need to learn how to draw these angles. Alright, so I have pi over 4 done. I graphed that one. How would I graph negative 7 pi over 4? Yikes, this one's hard. Jonah?
So obviously be going down,
Mm-hmm.
and it would be at the in between 180 and 270.
Well, let's see. So between 180 and 270, so I'm going -7 pi over 4. So the negative means instead of going counterclockwise, I'm going to go clockwise. And I have to go 7/4. So here's 1/4.
So you
2
go
fourths,
around a full
3/4, 4/4, 5/4, 6/4, 7/4. Are we surprised it's ending up in the same terminal? Exactly, that's the whole point. Where it's a coterminal, I'm showing you, here's the positive angle, here's the negative. So Jonah, you were right. We just like keep going around. Has the same terminal. And then if I want to do -15 pi over 4, I kind of cheated by drawing the dotted lines. Okay, cool. Oh, wait. Okay. So if I want to do -15 pi over 4, I just count by the fourths. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11, 12, 14/4, 15. Did I miscounted? Ugh. I was trying to watch up there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I went around one whole time and then around. That's what I get for not looking at my screen. So surprise, they all end up at the same place. Okay, so that proves it. You will have to know how to draw like 2 or 3 angles on the same axes. All right, so let's continue. Let's have 2 more people. One person do C, one person do D. All right, let's do Maya and then Max.
Here, I'll come up, don't worry.
Perfect. Saw those eyes. It said, I will be going home.
So then positive, you're going to do 11 pi over 2 plus 2 pi over 1. Hey, we got to find the least common denominator. So then multiply by 2. So then 11 pi.
Multiply by 2 or 2 over 2?
I mean, you know what I mean. Plus 4 pi over 2, which equals 15 pi over 2. Hey, we're not done. Negative. So 11 minus 4, 8, 7.
So this is my negative angle, but
We need a negative.
so I think it was.
Is that wrong?
Michaela's like, oh, we just have to keep going.
Is that wrong? Or
No, this is right. Now you have to find a common denominator. Solid.
Oh, we keep having to go.
That's what I was talking about. You have to keep going until you hit a negative.
Wait, I messed up. Pardon. No, I messed up. So negative pi over 2.
Sweet. So we had 3 pi over 2 minus 4 pi is negative pi over 2. Awesome. Do you have questions? All right, and Max. Good job. Beautiful. Sweet. I love math. Okay.
No, I don't.
Okay. Oh, sorry. We need a couple more seconds.
So when you get to like, you get to like 11 pi minus 4 pi, that's
Yep.
7 pi.
Yeah, 7 pi over 2.
Okay, and then would you
We had
subtract
to subtract 4 pi over 2
4 pi?
again.
Okay.
Because when I'm subtracting 4 pi over 2, that's subtracting 1 revolution. It's kind of like this is a weird way, it's kind of like you're unwinding all the times it went over positive. You're like rewinding it 1 revolution at a time. Alright. We're good to move on? Give me one more time, writing. Okay. So awesome. So we had to keep subtracting 4 pi over 2 until I reached a negative number. That way we have a positive and a negative coterminal. So secretly, this 7 pi over 2 and 3 pi over 2 are also coterminal angles. If we graphed all of these, they'll all end up at the same place. The difference is this goes 3/4 the way around. This one goes all the way around once, and then 3/4 the way around. Or let's see, well, yeah, 3/4. And this one goes around 2 times. Actually, wait, this is 2 times. And this guy's 3 times around before it ends up. So they're all coterminal. We could graph them all on the same axes and we'd be fine. All right, I think that's enough time. Cool. So it's kind of as you're doing it. I have a question. Any water? Perfect. So which one are you finding first?
The
Which one
positive one.
Alright, are we almost done? It was so cute. Yeah, okay. Oh, thanks. Alright. Alright, Max, so walk us through what you've been doing. What's your train of thought? What's the method?
That's a 9.
How did you do this?
I just plugged in numbers until it worked.
So first you added 2 pi to have the positive coterminal angle. You had to find a common denominator, then add on top and you find an answer. How did you find the negative one?
I subtracted
Subtracted 2 pi.
2
Have to
pi
find a
instead of
common
adding it.
denominator.
Yeah.
Okay. So I'm trying to kill your brain with these problems. That way you will fully understand them. You will understand. All right. Yes.
For how did you graph the negative coterminal?
For B?
Yeah.
So negative 15 pi over 4. I started at the initial, and I'm going in the negative direction, so negative is clockwise, and I counted by fourths. So between 0 and pi, I split it into fourths, and I just counted by fourths. So I went around 15 fourths. Okay.
How do you know how many times you square?
Well, so here it said 15 over 4, so I knew that halfway between 0 and pi was half of pi. And so this right here is 1/4 pi, 1/4, negative 1/4. This is negative 2/4, negative 3/4, so I just went around counting that way. And I went till I reached 15 times going in the negative direction. Cool. All right, so now part C. I'm wanting to find a coterminal angle, positive and negative. Let's have, hasn't came up yet. Let's have Ari and Matt. Sure. You can do C and then she can do D? Okay. Yeah, okay, so being picky with words. E, F, whatevs.
Are we doing it, do you want it in pi or like in the third?
Well, so this is in degrees, so you should keep it in
Do you want
degrees.
okay, so you don't want like convert it, keep it with 15. Okay.
Alright, so I want you guys to try this yourself. I want you to put your pencil on your paper, try to solve this yourself. I'll give you 10 seconds and then Ari's going to go over it.
That's fine.
4 okay. So try this on your paper. It says C, mean E. You've not tried it already. Cool. So she saw his degrees. She just added 360. She had a positive number. She minus 360, and then she got negative. So those are my two coterminal angles. Right, Matt? Yep. Shabazz gonna what?
She's gonna write for me.
Perfect. Okay. Yeah.
That's so sweet.
Teamwork. Make the dream work.
Full participation for me.
That's the plan.
I'm really lacking on that. So.
Sure.
I do one after the next one.
Okay, so you're gonna do 60 minus the
Yes, I'm gonna ask.
or plus. Or yeah, you minus first, whichever.
Oh, okay, I just.
And that's gonna equal 420.
Sweet.
So that's gonna be 60 minus 360. It's gonna be negative 300.
Oh wow, we
And
really have a lot of practice.
there's
Sorry.
your answer.
Perfect. Well, practice makes perfect. Because then when you come up to me on the test and you're like, am I on the right track? I'll just be like, I don't know. Are you? I don't know. I really did not label these nicely.
Can I do F?
Hold on. Let's
Can I do one on that?
let's do E and F, and then we're gonna go on to the next
I could do one of them.
part. I want to do a harder problem. Let's see.
I'll do it first.
Let's do E and F, and then we'll go on. So E, let's have Tessa come up. She hasn't came up yet, and then F. Emily, do you want to do it?
No.
Okay.
Oh.
Jonah. Okay. Perfect. So E and F. So I want you to try it yourself. Try it, and then if we have questions, we'll see how Tessa's doing it.
Okay. Oh, it's magnetic.
Do I have one person who could summarize how do you find coterminal angles and how do we know when to like stop adding or subtracting? Can you summarize what we're doing, Matt?
Well, coterminal angles are pretty much an angle that is the same exact thing as your starting angle,
Exact thing,
meaning the same terminal and same that way.
yeah, same initial, same terminal, okay.
And then you need one positive and one negative.
Awesome. So you have to keep subtracting till you reach a negative angle. You have to keep adding till you reach a positive angle. If you have degrees, you're adding 360, subtracting 360. If you have radians, you're adding 2 pi, subtracting 2 pi. Solid. Alright, awesome. And then let's do the last one. Maya, you can come up and let's do, this is the last one we're going to do, and then we're going to move on. Snooze, you lose.
Wait, can you go back for a second?
No, she already did one. I didn't even do it.
Okay, I'm already up here.
It's fine, I'll ask you a
Isn't
question.
it 10 degrees for 7?
Well, 10 is positive, and we're wanting a negative coterminal, so you have to keep going to a negative coterminal.
Jonah, Crimea River, like actually.
Jonah,
Okay.
build a bridge, get over it. That's a good one.
Max. What's the calculation?
Oh.
I said it like 50
behind.
times last week. Someone said that to me.
You say it once.
90.
Is this 250?
70.
270?
So normally you have a calculator. I'm gonna let you have a calculator to make sure you add properly. No worries.
My bad. What?
400. Negative 450.
400?
450, yeah. Sweet. Oh, it's alright. That was just my screencast. Alright, awesome. Cool. Alright, so I feel like I've burned it into your brain, so let's go on to the next step. You can say cool. Alright. So there's 4 more questions. If you still have questions over... There's a lot of noise. I'll wait. Let's all face front of the room. Let's sit up, Chloe. This is not nap time, Tessa.
For the test like this, are we gonna have to be able to
Draw them.
in radian?
Well, no, you have to be able to. Okay, when you say graph, like graph by hand, yes.
Well, graph
You have to
by
draw.
graph. Are we gonna have to graph radians rather than in degrees?
You have to know how to do both.
Okay. Can we review more on those?
I'm glad you're asking about how to draw radians because that's the next thing we're doing. So patterns and radian measures on the unit circle. Look at Tessa. It's like I gave her a 20 and told her to say that. A transitions.
Participation points.
Yeah, because you had 2 problems. Who said this? Ari? Yeah, you did too. All right, patterns and radian measures on the unit circle. So to find the angles equivalent to pi over 6 in each quadrant. Okay, what does quadrant even mean? Quad, so...
The 1, the 2, the 3, and 4, and they're Roman numerals.
Oh my god, wow, we do remember this. Okay, so here's 1,
2.
2.
Matt, you just
But you just put a 3,
Yeah.
silly.
Trick play. I got a little happy drawing. Okay, so I have quadrant 1, 2, 3, and 4. So in each quadrant, I'm talking about, okay, so there's an angle that's going to be equivalent to pi over 6 in each of the quadrants. So quad means 4. So quadrants, I divide my graph into 4 parts. So we're going to count the coefficients of pi over 6. The ones that do not reduce are equivalent to pi over 6, meaning if I can't simplify the fraction. But first, what is pi over 6 as degree? Can we do that? Pi over 6. To get 2 degrees, what do I do, Ethan?
Times pi over
2 pi?
How do I go from radian to degree?
Oh, I think I know.
6 over 6.
Multiply by the reciprocal. No.
180
No.
over pi.
180 degrees over pi. That is how you go from radians to degree.
Wait, so
This is a trick because we did something super similar to this before. 18 divided by 6 is 3. 180 divided by 6 is 30. Okay, little matrix. So this is 30 degrees. We have an idea of where 30 degrees is thanks to geometry. Yes, Jonah?
2 things. One is be in the middle of 0 and 90. And also,
It's between 0 and 90.
like more towards 0, but like,
More towards 0.
question. So I remember yesterday you had pi over 180. Is that when you kind of convert to
So the trick is, what am I wanting to convert to? If I'm wanting to get to degrees, degrees should be on top.
Oh, so if the pi.
If I want to
on the
get
left
rid
is on
of
the
degrees, degrees has to be on bottom, so it'll cancel out. Yep. All right, so I think we started class with like going over the rules. How do you go from degrees to radians and radians to degrees? It's definitely, I would write that down when you're going over your homework. Make sure you know how to do that. All right, so we're looking at something with 30 degrees. So if I basically draw out all of the 1/6 pieces. Let's see. Oh gosh, that's not right. Something like this. So what I want you to notice is there's 1 piece, 2 piece, 3, 4, 5, 6. 6, 6 is the same as pi. Okay, so that's secretly what is written on your paper. It doesn't have all these lines on it. But the only lines I kept on there were the ones that the coefficient, the whole fraction doesn't actually reduce. I can't simplify it. Because if you look at 2 pi over 6, what's this the same as? Can we reduce this?
Yeah.
What is it equal to, Ari? Pi over 3. Okay, so this is pi over 3. We know how to reduce fractions. What? I don't know why I did that. 3 pi over 6. 3 6s, half, half. 4 6, 2/3. So all of these ones that did not box, you can actually reduce. So there's really only 4 fractions. There's only 4 pieces of my, so I cut my pizza into 6 pieces to get to pi, 6 pieces to get back to 2 pi. But there's really only 4 of them that will have the same equivalent angle measure as pi over 6. Okay, so from geometry, if I would have these 2 lines right here, what do we know about the measures of this angle and this angle?
The cube.
They are equivalent. Vertical angle theorem. Vertical angles are equivalent to intersecting lines. Okay, so geometry already taught you this. And what about, so if these are equivalent, and then I split them in exactly half, that tells you that this angle is the same one as this one.
Yes.
Maybe? Okay, if we don't see it yet, that's fine. Throwing in some geometry. So secretly, here we have pi over 6. And then I have 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. But only the ones that can't be reduced are equivalent to pi over 6. So it's this angle, this angle. These are equivalent angles. We might not see it yet.
No, I see it.
What should I be labeling this angle right here? What would I label this?
7 pi over 6.
Ah, 7
And
pi over
11
6.
pi over 6.
And this is 11 pi over 6.
I get it. If you
Okay.
turn the paper,
You turn it, exactly.
it just looks like a straight line through the middle.
So then 7 pi over 6.
Exactly.
On one
and-
side it's 2 pi, and on the other side it's pi, and then your circle just shifted. Like,
Yeah, let me highlight this line and this one right here. So I know that this angle is going to be equivalent to this one because it's a vertical angle theorem. I don't know if we're understanding it. Matt, do you have a question?
No, actually.
Okay, cool. So just so we'll face forward. Okay. Okay, so I'm throwing in a lot of geometry. Literally this whole chapter is from geometry. We went over SOHCAHTOA, we're using special triangles, now we're talking about how they're equivalent. I'm giving you the definitive proof, or you can just be like, yeah, they're equal. Yes?
So I totally get like the why they're equivalent and
Mhm.
all that stuff. I'm just like what is the point of it? And
The point,
other,
okay?
The other ones that like you added in, like do you need those to figure out the other angles?
Nope.
So are basically right now are you just saying like they're equivalent, that's it?
Yes. That's pi over 6 has this 30-degree angle between the x-axis and the terminal ray. And if I look at the x-axis over by pi, so if I'm looking at this x-axis right here and the terminal, this is also 30 degrees. It's also pi over 6. So this angle measurement between these two rays, right? So between these two rays, that's the same as this guy right here.
How would you like have to label them to know which one is the like pi over 6 angle? Because I don't understand like
So okay.
know which angle is the one if you don't.
Okay, so I see your question. I feel like maybe if we keep going in the lesson, you would see where I'm trying to go with this. Trying to have you guys understand reference angles, but right now you're like, I don't know what a reference angle is. So I'm trying to prove to you, hey, if these two are the same, we can use an angle between 0 and 90. So it's getting a little ahead of myself. Let's go to the next one. Just going to walk you through. So to find the angles equivalent to pi over 4 in each quadrant, count the coefficients. So I label from 1/4 all the way to 2 pi. 2 pi is the same thing as 8 pi over 4. So we kind of did this with coterminal angles. So I label 1/4 pi, 2/4 pi, 3/4 pi, 4 pi over 4, 5 pi over 4, all the way across. And any single one that can't be reduced, these are going to be the equivalent ones. So if I label this is pi over 4, this middle one is 2 pi over 4, but I know that's the same thing as
1 over 2.
1 over 2, pi over 2. This is 3 pi over 4, and the next one is 4 pi over 4, which is the same thing as 1 pi. 5 pi over 4, and this one's going to be, well, let's see, I already labeled 5. What's this last one?
4. So 3.
Well, let's see, this is 6 pi over 4.
7.
This is 7 pi over 4. Okay.
What about this?
So if I look at the angle that's between here, how does that compare with the angle that's between these two rays?
The same.
They're the same. So notice that I'm going between the terminal ray and the x-axis. The x-axis is what I'm using to show that they're equivalent. Okay, so now if I go to pi over 3, let's go ahead and let's label. This is pi over 3. 2 pi over 3 It's like I'm going by thirds. Here's 1/3, 2/3, 3/3 is the same as 1. 4/3 pi, I can't reduce anymore. This is 5 pi over 3. And if I go 6 pi over 3, that's the same thing as 2 pi. So here are two important angles. Let's see. So I'm looking at this angle between the terminal ray and the x-axis. Between the terminal ray, the x-axis, I'm always looking between the x-axis and my terminal ray. Okay, so now let's put it all together. Yes, Tessa?
So are you always going to give us like other values to label, or like, I'm just confused, like how we do this along, like are we given like on a test? Like,
so right now this part is I'm trying to lead you into the next thing.
Okay.
So you only can do half of the homework for 12.2. So this is putting it all together. So we're going to label all the special angles. So we know 2 special triangles. So I think this is what you're asking. We know 2 special triangles. 45, 45, 90, and 30, 60, 90. Okay. So what I'd love to do is label 30 degrees, 45 degrees, 60 degrees, and all of the multiples of them. So wait, that's exactly what we've been doing. The last 3 examples we went through, I labeled all of my 30-degree angles. I labeled all of my 45, all of my 60, but the difference is I only kept the ones that were strictly with 30 that could not be reduced at all. So let's go through and let's label this smartly. Let's go with the angles that lie on the x and y axes.
Okay,
So let's see, let's slow it down a little bit. Let's slow it down just a tad. First, here's my initial ray. If I have an angle that lies on there, if the terminal lies on there, let's start in the back. Emily, what would this angle be that goes right here? That's with the blue, and if it ends in this place as well? 0 degrees or 360, what would this be in radians? Zero radians, or 360 is equal to how many radians? 2 pi. Yep. So this is something you need to know. Radians. What about the one that's along the positive y-axis? Zach? So I'll say this is 90 degrees, or how many radians? So 90 degrees or pi over 2. Okay. If I want to look at the negative x-axis, what angle lies along here?
180.
180, also known as in radians. Let's see. So I'm halfway between 0 and 2 pi. I'm halfway around.
So pi over 4.
So if I go all the way around is 2 pi, halfway around is going to be half of that. So just pi. So 180 is equivalent to pi. It means the same thing. 180 degrees, pi radians. And if I go 3/4 the way around, so the negative y-axis, what would this be labeled as? Who should I call on? How about Carson? Do we know? Liana? Well, so if I start at 0, it's okay. 0, 1/2, 1,
1.5.
1.5. What's this as a fraction? 3 over 2. 3 pi over 2. Or I believe someone said 270. Okay, so those are the easiest ones. Which would you like to do next, Chloe? Which one do you want to do? 45, 30, or 60? All right, so let's label the 45 ones. How do I know where 45 is located, Michaela? 45 degrees. It's an acute angle, but if I labeled 0 and I labeled 90, what's the trick I'm looking for, Michaela? It's exactly half, directly half. So which of these is exactly halfway between 90 and 0? The middle one. So all of these, the ones I highlighted in 0, are the 45-degree equivalent angles. Okay, so I highlighted them, and we know what these are because we just drew them. So this is pi over 4. What's the next one on the left side in the quadrant 2? Which angle is this? If you don't know, let's look at the page before, because we're trying to combine all three. 135 degrees, also known as 3 pi over 4. So this picture is exactly what this one, oh, sorry, this one. This is the one. Yeah, these are all the blank pi over 4s. 5 pi over 4, 7 pi over 4. Now let's label all the 30-degree angles. So the 30 is the smallest one, closest to the x-axis.
That's pi over 3.
These are pi over 6, because it's 30 degrees. We can go back and do the degrees for later. Pi over 6. So what are the other 3 angles going to be? Can we look back at our notes?
3 pi over 6.
5 pi over 6, 7 pi over 6, and 11 pi over 6. And then we're going to end with this last one, which are the 60-degree angles, which is pi over 3. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So this is the start of the unit circle using our 3 special angles. So we're going to continue and put this all together with reference angles when I see you guys on Thursday.